Hello everyone. In this video, we are going to solve the today's LeetCode problem of the day, that is power of 4. So let's open the problem. So the question is power of 4 and the question number is 342. So let's read the problem. The problem states that given an integer n, return true if it is a power of 4, otherwise return false. Okay, if an integer is power of 4, if there exists an integer x such that n can be written as 4 to the power x. Okay, and the constraints lies between minus 2 to the power 31 to the 2 to the power 31 minus 1. That is the range of integer. Okay, so the question states that we are given an integer n. We are given an integer n, and we need to find it is a power of 4 or not. Is it a power of 4 or not? So if it is power of 4, yes, then return true. If it is not power of 4, then return false. So what we can, let's take some examples. For example, 1. 1 is power of 4 or not? Yes, it is a power of 4. Why? Because 4 to the power 0 equals to 1. So 1 is power of 4. Is 2 is power of 4? No, 2 is not power of 4. Why? Because we cannot write 2 as power of 4. So 2 is not power of 4. Is 3? Not. Is 4? No. Yes. Why? Because we can write 4 as 4 to power 1. Similarly, we can write 16 as power of 4 as 4 to power 3, 2, as 64 as 4 to power 3. And another example is, can we write any negative number as power of 4? Can we write minus 1 as power of 4? No. Can we write minus 4 as power of 4? No, because we can write 4 as power of 4 as 4 1, but 4 to power 1, but not minus 4. If we try to write minus, so it is not possible. So if n is less than equals to 0, then we always need to return false. This is a kind of our one, we can say, assumption, or we can say our base case. So let's move to the basic approach, or we can say brute force approach. So what we can say is, if n equals to 1, then return true. If n is less than equals to 0, return false. If n mod 4 not equals to 0, why? Because a number can be written as power of 4 only if it can be completely divisible by 4. So we can return false, and we can iterate over this condition, like we can call this function recursive function as is power of 4 n by 4. Okay, so for this code, let's write this in code basis. Okay, example, we can write is power of 4 int n if n is less than equals to 0, or n mod 4, wait, we need to write this condition first. If n equals to 1, then return true. If n is less than equals to 0, or n mod 4 not equals to 0, then return false. Else what we can do, return is power of 4 n divided by 4. Okay, so this is our brute force code. So let's take about its time and space complexity. Its time and space complexity. For a space complexity will be big of 1. Why? Because we not use any variable and all. The space complexity will be unit big of 1. What about time complexity? So here, after every iteration, our n decreases by, we divide it by 4. So we can tell like it's something big of logs to the power 4 of n, or we can simply say it's as log of n. Yes, so the time complexity of big of log of n. So but here let's read the follow-up. Here it tells us, could you solve it without loops or recursion? So we need to solve without loops or recursion, but here we use recursion, and its time complexity is big of log of n. So can we optimize it? Yes, we can definitely optimize it. Assume another examples. For example, another approach 2. So here let's assume what we can write for in binary. We can write it as 100. What we can write is 1 1 2 10 3 11 4 100 5 101 6 110, like a 16 1 0 0 0 1 2 4 8, yeah, something like 1 2 4 8 16. And similarly 64 we can write 1 something like that. 1 2 4 8 16 32, no, this. Okay, so here for we can conclude that if a number is power of 4, if number is power of 4, then what is the condition? It contains only one set bit, and the another condition is the position of set bit is always odd. How can we say that? Is, let's assume here for 1 it lies at first position, for a for 16 it lies at 1 2 3 4 fifth position, for 64 1 2 3 4 5 6 7 seventh position. So every number which is so this is the two condition. If any number is divisible is power of 4 only if it contains only one single set bit, and the second condition is that the position of set bit is always odd, otherwise we can return false. Okay, so its time complexity will be, its space complexity will be again big O of 31, or we can say big of 1. Why 31? Because we need to store, or if we want to store it in arrays, like position of set bit in array, then we can use 31, big of 31 hoga. Else if we can do it by right shift, then it becomes big of 1. What about its time complexity? Time complexity will be again 31, because why? Sorry, big of 32. Why? Because 2 to power, the range is from 2 to power 32 minus 2 n less than equals to 2 to power 31 32 minus 1. So any number can be represented within 32 bits. So the time complexity will be big of 32. So let's move to the optimized way. So for this we can say, what we can say is third approach, that is our most optimized approach. So for if n is less than equals to 0, what we need to do? We need to return false. If, and what we can do is we try to write every number as power of 4. So how can we do that? For example, if number is 1, we want to find this power. We want to find the exponent. We for its exponent will be 1. For 16, its exponent will be this. So we want to find the exponent. So how can we find the exponent? So for finding the exponent of 4, we can write any number as log base 4 to the power n. So we can get the exponent of 4. So for that, what we can do is we can take a variable double exp equals to math dot log of n divided by log of 4. What? Why? Because we can write log 4n as log n, log 10n, or by log 4. So similarly, so in the same way we can implement this, and what we can check is if exp equals to floor of exp, then return true, otherwise return false. Why we need to check this floor of exp? Because if number is 16, then its power is 2, exponent is 2, we get exponent is as 2. And if the number is 2, if a number is 5, then its exponent will be something like 1.2 something. So then floor of exp and exp doesn't match, so we return the false. Okay, hope you understand the concept. Let's move to the code part. If n is less than equals to 0, what we can do is we can simply return false. Else int a sorry double exp equals to math.log of n divided by math of log of 4, and what we can return exp equals to floor of exp. mm, mm, let's check. Oh, we need to write math.floor, sorry, math.floor of exp. So here it runs on the sample text. Let me submit. So the question passes all the test cases, accepted. So let's talk about this time and space complexity. So the time complexity of this code will be, what will be the time complexity? We do only unit task. We just check if a number is less than equals to 0, return false, and we check the log, check, find the log base 4 of that number and check. So time complexity will be O of n, and space complexity will be also big of 1. So the time and space complexity will be unit time, it takes unit time and unit space. Hope you understand the solution, and the code will be given in the description or comment. Thank you.